There's a lot you can do with a Linux server, and people are discovering clever new use cases all the time. But given that so much of the massive volumes of data generated and consumed by the internet uses the HTTP protocol, to make it all work for you, you'll probably want to introduce yourself to whatever software you'll need to help data speak HTTP's language. Such software is technically known as an HTTP server program, and for years the most popular program of them all has been an open source package called Apache. Technically, the package is called Apache HTTP Server, whose maintainer, the Apache Software Foundation, a non-profit corporation, is also responsible for hundreds of critically important and widely used open source projects. Apache's first job is to direct incoming requests for data to the locations on a server's file system where a website's files are kept. But Apache is also at least partially responsible for making sure that only appropriate external requests are satisfied, and that through encryption, connections deliver data in a reliable state. Apache normally runs on Linux as part of an integrated platform, often called a LAMP server, where the L in LAMP stands for Linux, A for Apache, M for the MySQL relational database engine, and P for the PHP scripting language. Of course, you're not restricted to exactly that combination of components. You could, for instance, substitute a different database like MariaDB for MySQL, and another scripting language like Python for PHP. But the traditional LAMP setup is reliable, predictable, and popular. So popular, in fact, that Ubuntu's apt package manager includes a package called LAMP Server that bundles the installation for the whole platform into a single command. So I'm going to actually install the package right now before your astonished eyes, and then take you on a bit of a tour of the place. If you want to build just about any kind of LAMP-based web service, you'll need to have at least a basic understanding of each of the parts and how they all work together. Here's the one-stop shop installation. Don't forget to include the Carré character at the end of the line. Everything should install in this clean LXC container without my intervention, besides a request to set up a root password for admin access to the database. When the install is complete, you should be able to use the web browser on any computer with access to the network to browse to the server's IP address. The Apache default welcome page should load. That's how it'll happen on an Ubuntu machine. You'd need to open up the firewall to allow incoming web traffic using a command something like this on CentOS. This is fully discussed in Chapter 7 from Linux in Action. Let's see how that worked. Back on the server, I'll change directory to the web document root in var www.html. When an external web request is received, Apache will look here for useful files that fit the request. By accepted convention, the first file delivered in response to a request will be one named index.html. This index.html was automatically created in this directory as part of the Apache installation. I'm going to create my own HTML file called hello.html in this directory using a text editor. This won't be anything special, just a proof of concept. Once I've saved the file, I can go back to my browser, enter the server IP address along with the name of my new file, and we've got ourselves a customized website. While we're here in the document root, I'll give you an idea of the role that PHP can play in managing public-facing content. First off, I'll create a PHP file called info.php that will display basic PHP configuration data to a visiting browser. The file will contain nothing more than the command php-info within a PHP tag, identified by this angle bracket question mark combination. The info file that's displayed first shows you some basic PHP configuration information, including Apache integration details, relevant environment variables, and all the way down here, some default PHP variables. Let's take this script file name variable to see what it can do for us. I'll open a new file I'll call script.php and paste the variable between the PHP brackets. Save the file, and open it in my browser. All it does is display the name and location of the script.php file by itself. But you can probably see how this kind of information can be useful for incorporating dynamic server configuration data into longer and more complex scripts. This little tool can be really useful for orienting yourself within your system. But make sure you remove the info.php file before putting your site online. This kind of information should never be publicly available. By the way, PHP will often be used by applications like the popular WordPress content management system without your being aware of it. Want to see how important PHP is for such platforms? Just shut it down and see what happens to your WordPress site. What about MySQL? Well, a simple website that consists of plain HTML pages, a CSS file or two, and media resources might have no need for a database to handle changing data. But for those sites that do rely on storing and retrieving data, you'll appreciate the out-of-the-box integration provided by the LAMP system. Take WordPress as an example. All the text that populates your site's pages and blog posts has to be stored somewhere, and one look into an active WordPress file system will show you that the content is not being stored as plain text files in the same way as my hello.html page. So where's it all hiding? In a relational database like our MySQL. The setup involves creating a WordPress user in MySQL that will have rights to create and administrate its own data. By passing along the user's credentials, you'll give WordPress the ability to invisibly use the database to function as a CMS. As far as this course goes, let me just quickly help you visualize the MySQL interface. You log in from the command line using -u to specify we're logging in as the root user, which so far is the only user that exists. -p tells MySQL to prompt us for the root password. Once inside the MySQL shell, we're now subject to a different set of rules. Probably the most obvious, and until you get used to it annoying example, is the need to end each command with a semicolon. Just so I can see what's already there, my first command will be to list all the existing databases. These will all be system databases used for the basic function of MySQL. Now, to show you how to find and access some of the data treasures kept here, I can switch to a subshell. Let's try out the MySQL database. Listing the tables that make up the database suggests that this table tells MySQL what kinds of tools it has available for our use. Most of these tables contain a lot of data that won't display nicely on a small terminal screen like this one, but selecting all records from the server cost table shows us a helpful tool for managing project cost estimates. Exit will quit the shell, but by the same token, typing quit will also exit. Your choice. We've seen a bit of both PHP and MySQL. Now how about a look at Apache's configuration? The Apache configuration files live in the etc apache2 directory. The apache2.conf file contains some system-wide configuration settings. This is where you control the program's global behavior, covering facilities like logging, default file locations, and redirection. But what I really want to show you is the site's available directory, and in particular, the 000default.conf file. Here is where you tell Apache how to deal with requests. This particular file is bare bones. Besides all the commented outlines that aren't read by Apache and are only meant as documentation, there's only a single active section called virtualhost that will send all incoming requests using port 80, the standard HTTP port, to the document root, var www.html. This explains how Apache knew to provide us with the index.html and hello.html files earlier when we hit the site with our browser. How you'll edit this file to accommodate more than one distinct website is something we'll discuss in the next video. Why would a normal, red-blooded sysadmin ever want to host more than one website on a single server? Because it can save you buckets of money and tons of wasted time, and because it's cool. Let's dig a bit deeper into those buckets of money and time. While a cloud-based virtual machine is dead easy to fire up, it does cost money. You can get lots of insight into how all that works from Chapter 3 of my Learn Amazon Web Services in a Month of Lunches book. But to simplify the story, a very lightweight AWS EC2 instance is going to cost you at least $55 a year when purchased as a 3-year reserved instance. That's not an awful lot of money for the value you're getting, but if your server normally doesn't attract enough traffic to max out its resources, and you're hosting other websites using their own DNS domains, then why not share a single server? True story. I personally host multiple websites using only one lightweight EC2 instance. I'm going to show you how that works, at least from the Linux end. To do this in production, you'll also need to edit the domain resource records provided by your DNS service provider. You can learn more about that in Chapter 5 of Learn Amazon Web Services in a Month of Lunches. But since there's nothing especially Linuxy about that stuff, I'll leave those details in your hands. What we will need to do for this demo, however, is fake a live domain name so I can point the browser on my desktop computer to, say, newsite.com, and it will direct me to my LAMP server container here on my own network. You can do that by adding a line to the hosts file in the etc directory. By the way, except for the location of the file, this will work pretty much the same way on Windows and Mac OS. I'll enter the IP address of my LAMP server and then associate that IP with the newsite.com domain name. Since the first DNS dictionary any browser will consult when looking up a host is the local hosts file, regardless of the existence of a real newsite.com site out there on the internet, your browser will send this newsite.com request to this IP. Just for completeness, I'll also add a record matching the IP with the www.newsite.com alias. Now I'll move back to the LAMP server and create a new site directory below the document root var www.html. I'll use echo to add some text. The BR tag is just a little formatting, telling browsers to insert a new paragraph. The greater than character will write the text to a file called index.html. If it doesn't exist yet, the command will create it. If it does already exist, bash will erase everything there and replace it with this new text. If, by the way, you wanted to append the new text to the end of an existing file rather than wipe it and start from scratch, you'd use 2 greater than characters rather than just 1. With that done, using sudo because var www.html is a system directory, I'll copy the new file to the new site directory I just created. That's our second website done. Nothing to it. All that's left is to configure Apache so it'll know what to do with the browser request that'll soon be coming its way. Let's head back to that 000default.com file. We'll add a second section. This time entering newsite.com as the value of server name, var www.html newsite as the document root, and a server alias of www.newsite.com. I'll hit Ctrl X to save and exit the file, and then restart the Apache service so it'll be updated on the new configuration. With that done, I'll return to the browser on my own workstation and see what's new with my favorite website, newsite.com. That's what I was hoping for, my index.html page. But is this truly a multi-site server? What happens if I point my browser to the server's IP address? There's the Apache welcome page, just where we left it. And www.newsite.com? Bingo! We're in business. I should note that placing multiple directives in the 000-default.conf Apache config file is the Ubuntu way of doing things. You'll find that other distros are more likely to use separate config files for each virtual host you're hosting. It's all good. What's not good is running public-facing resources using unencrypted and therefore vulnerable plain text HTML. The example I just showed you is an important building block for more sophisticated websites, but as you saw, it'll work through port 80. That's fine for the kind of private experiments we play with as we learn, but it's no longer good enough for production environments where you're using data that you'd rather wasn't freely available for anyone who happens by. Adding encryption to our configuration is actually quite simple using the free certificates from the Let's Encrypt project and the certbot installation tool. I described the process in Chapter 9 of Linux in Action. To practice what you've seen here, why not put together a LAMP server and build your own multi-domain web server, but encrypt it? That part's free. Let's review. You learned how to install a LAMP server, perform simple MySQL and PHP tasks, and create and expose HTML files in the Apache document root directory. You then explored the world of the multi-domain web server, understanding how Apache can be configured to reliably manage server resources among more than one domain or IP-based website. Coming up next, securing the server you built using object permissions and firewalls.
If you're enjoying this video series, you'll be glad to know that it's just a small part of a much larger course that can be found on Manning's live video platform. Live video contains a variety of courses for software developers and engineers, and features helpful tools like an interactive transcript and intuitive integration with our live books. You can find David Clinton's Linux in Motion and other courses at Manning.com. This is the final part of a 3-part series featuring excerpts from David's course, so click the links to watch part 1 and 2.